Hi, Integrated Math 1. Welcome back to boot camp. We just got to come back, review a few things. No big deal. We're actually going to spend 2 days on this just because it's kind of important. And I know some of this is review for you guys. It's going to be really easy. But I just want to make sure that we're solid on it before we move on to our exponential functions because it's kind of relying on us being pretty good with this stuff. So just to get the party started, just a few reminders. Again, things you already know, and I know this and you know this, but still good to remember. Please remember that anything to the zero power is 1. You remember that? So like 3 to the 0 power is 1, 25 to the 0 power is 1, 364.72 to the 0 power is 1. Negative 67 to the 0 power, depending on where the negative is, it's 1. So anything to the 0 power is 1. Please remember that. Please keep that in mind. Now, the other thing I want you to keep in mind, it's a small but important detail, and that is negative exponents. I'm sure you've seen them before, but just remember that a negative exponent becomes positive by dividing 1 by the entire power. I often like to think of it as the reciprocal of the base makes your power a negative power positive. So if you have a negative exponent, you can flip your base, you can do the reciprocal of your base, and that will give you a positive exponent. So for example, if I have 3 to the negative 2 power, well, the reciprocal of 3 is 1 over 3. So instead of 3 to the negative 2, I can write this as 1 over 3 squared. And of course, we know 3 squared is 9, and so that becomes 1/9. So to keep this moving just a little bit more, I have a couple of examples for you to try. Go ahead, hit pause to work all these out, and then hit play when you're ready to check your work. So I do apologize if you can hear my cat in the background. I think she's not happy that I'm working at home today. So real quick, let's simplify a couple of expressions. 10 to the negative third power, we were just talking about this. I don't like the negative power. I can turn that negative 3 into a positive 3 by flipping my base. So instead of 10 over 1, I'm going to make it 1 over 10. So now I have 1 to the over 10 to the third power. And this I can easily work out. I mean, 10 times 10 times 10. If you need a calculator, I guess you could use one. Don't know that you need one. But 10 times 10 times 10 is, of course, 1,000. So this becomes 1 over 1,000. And yes, Charlotte is joining us today. Sweetheart, yes, thank you. You're lovely. You're adorable. I'm working. For part B, I'm not worried about the negative 4 in the numerator. That's not where the problem is. The problem is that negative 4 exponent. I have k to the negative 4th power. But we said we could make our exponent positive just by flipping it. And yes, I am petting my cat while we're doing this. Just by moving it to the other side of the fraction. So the negative 4 on top, that numerator, he's going to stay where he is. But to turn that negative 4 exponent positive, I'm going to move the k from the denominator up to the numerator. So now I have negative 4k to the 4th power over 1. Well, and I guess I don't really need it over 1, right? I mean, it's just negative 4 times k to the 4th power. Yay. As I look at C, I'm not worried about the negative 3 for my base. I'm worried about that negative exponent. So this is actually very similar to A, where I can make that exponent positive by flipping my base. So I'm going to say this is 1 over the quantity negative 3 to the 4th power. Now, please be careful. Negative 3 times negative 3 times negative 3 times negative 3. Negative negative is a positive, times another negative is negative, times another negative is positive. 4 negatives make a positive, guys. So this becomes 1 over 81. We got a couple tricks going on here in D, so I hope you're really careful. First of all, I'm not worried about y to the 5th. He's got a positive exponent. I'm just going to leave him where he is. He's totally fine, totally okay. I am going to worry about x to the negative 3rd power. I'm going to move it down. I'm going to move it below to make that negative 3 exponent positive. And of course, a to the 0 power, anything to the 0 power is 1. So a to the 0 power becomes 1. X to the negative 3 power becomes 1 over x to the positive 3 power. And we still have y to the 5th in our denominator. I don't need the 1 there, so I'm just going to clean it up a little bit and say it's 1 over x cubed y to the 5th power. How'd you do? You're right? Let's keep going. The product of two powers with the same base is that base raised to the sum of the exponents. Now that sounds fancy, but actually, you know this one. If I have 6 to the 7th power times 6 to the 4th power, I'm just going to, because the bases are the same, I can just add my exponents together. So this becomes 6 to the 7 plus 4 power, which is 6 to the 11th power. So if you're multiplying two powers with the same base, you can just add the exponents together. Pretty straightforward. I'll give you a few minutes to try that out. I've got a couple of these here. Go ahead and hit pause to work these out and then hit play when you're ready to check your work. My cat is sitting here staring at me, though at least she's not pestering us at this point. So here I have 2 to the 5th times 2 to the 6th. So this means I have a base of 2, and I can just add together my exponents. 5 plus 6 gives me 2 to the 11th power. If I really wanted to at this point, I could grab a calculator and figure out what 2 to the 11th power is. I'm not that desperate at this point in time because it's just going to be a big number. It's going to be a big number. On B, I have a couple of different ones. So I put the 4s together and I put the 3s together. So 4 to the 2nd power times 4 to the 5th power. So that's going to be a base of 4, and I'll add my exponents 2 and 5. And I put the 3s together, 3 to the negative 2 power times 3 to the 6th power. So 3 to the negative 2 plus 6 power. Ooh, that becomes 4 to the 7th power and 3 to the 4th power. Negative 2 plus 6 is 4. Yay. And again, if I wanted to at this point, I could grab a calculator, find out what 3 to the 4th power is. I believe that's 81. But I don't know 4 to the 7th power. I just know it's going to be really, really big. So I think I'm going to leave it like this for now. A little less stressful. For C, B didn't match with anybody, but I sure could put the A's together. So a to the 4th power times a to the 2nd power, 4 plus 2 is 6. So that becomes a to the 6th power, and the b to the 5th power just hangs around. He's not the same as the others, doesn't have the same base, so I'll just leave it. I am going to point out one tiny little thing here. Y squared times y to the negative 4. Did you catch that naked y? Please remember, if you don't see an exponent, it has an exponent of 1. I hope you remember that, because that means these all have the same base, and I'm just going to add my exponents. 2 plus 1 plus a negative 4. 2 plus 1 is 3, plus a negative 4 is a negative 1. Oh, and this goes back to what we were just doing earlier. I don't like the negative exponent. So I'm going to rewrite that as 1 over y to the 1st power, although I guess I don't need the 1 there. So I'll just rewrite it as 1 over y. How'd you do? Let's keep going. A power raised to another power is the base raised to the product of the exponents. That sounds really fancy. Let me show you what I mean. Here I have 6 to the 7th power being raised to the 4th power. So this just means I'm going to have a base of 6, but it means that my power of 7 is going to get multiplied with my power of 4, and I'll have 6 to the 28th power. So I like this. This is pretty straightforward. I keep my base, and since I have a power raised to a power, I'm going to multiply my exponents together to get my new power. So try it out. Hit pause, try these out. Hit play when you're ready to check your work, and I'm sure my cat will interrupt us soon. So the first one's pretty straightforward. 7 to the 4th power raised to the 3rd power. No big deal, no big deal. That means it's going to be 7 to the 4 times 3 power, and 4 times 3 is 12, so 7 to the 12th power. And again, if I wanted to, I could grab a calculator. I could figure out what that is. It's going to be really, really big, though, so I don't want to mess with it. 3 to the 6th power raised to the 0 power. Now you could do this really fast because anything to the 0 power is 1. But if you want to go through the steps, this is 3 to the 6 times 0 power. 6 times 0 is 0. And 3 to the 0 power is 1 because anything to the 0 power is 1. You could have totally just told me that was 1. You really didn't need to go through the steps on that. But if you want to see it, I have it there. This one required a couple of steps, right? So first I multiplied x to the 2 times negative 4 power, and of course 2 times negative 4 is negative 8. But then I have x to the negative 8 times x to the 5th power, so that means I can add those exponents together. Negative 8 plus 5 is a negative 3. Don't like the negative exponent. So I rewrote x to the negative third power as 1 over x to the third power. Just makes things better, easier, prettier. You know what I mean. One last little thing, and then we'll do a couple more examples and we'll call it good. We're almost there. A product raised to a power equals the product of each factor raised to that power. And the way I think of this is that everybody inside gets the power. It's almost like you distribute the power. So for example, if I have 2 times 4 being raised to the third power, and again, my cat's attacking. It's all good. Yes, go play with that, sweetheart. I could do 2 times 4 and then give it a power of 3, but what I want you to see is that this can be broken up. That everybody inside, because this is a product, because they're being multiplied, this doesn't work with adding or subtracting, only works with multiplication and division. Next time. And that is that I can rewrite this as 2 to the third power times 4 to the third power. Now this only works if you're multiplying insides. It doesn't work for addition or subtraction, but it does mean you can kind of distribute the power. Everybody gets the power. Yeah. You ready to try some? Last example. I would like you to try these out. Go ahead and hit pause, work it out, and then hit play when you're ready to check your work. Now, you guys are wise enough to know that negative 3x squared is just negative 3x times negative 3x, which is a positive 9x squared. But if you want to see the process, and again, you totally could have done that in your head. If you want to see the process, you can think of it as, well, this negative 3 gets a power of 2, and the x also gets a power of 2. Negative 3 squared, negative 3 times negative 3, positive 9, and then, of course, we have x squared. Now, you may have thought B was the same problem, but it's not, because notice that the negative is outside of the base. That negative does not become part of the power now. So this means the negative is just going to hang out up front, and we'll do 3 squared and x squared. And of course, 3 squared is 9, x squared is, well, x squared. But the negative was no longer inside my base. Did you catch that? So that means I ended up with the negative just hanging out in front. It's a little different, right? It's just like a little different. Here I have x to the negative 2 power times y to the 0 power, all raised to the third power. Now again, I know you know y to the 0 power is 1, and you could just worry about this, but I'm going to go ahead and distribute my power. I'll show you all the steps. It's okay if you skip some of them yourself, that's fine. And beware, my cat is about ready to interrupt again. So this is x to the negative 2 power raised to the third power times y to the 0 power raised to the third power. And of course, negative 2 times 3 is a negative 6. 0 times 3 is 0. So this becomes a 1, and I'm going to rewrite this instead of x to the negative 6, just like earlier. I'm going to rewrite it as 1 over x to the 6. Just a little neater, a little nicer, fewer negatives. How'd you do on this last one? Did you reach this one and go, oh my gosh, it got a little crazy, right? So I took them a chunk at a time. I started with this first chunk and I was like, okay, x squared to the 4th power, y cubed to the 4th power. And then I did x squared to the negative 4 power and y to the 4th to the negative 4 power. So I just put everybody in their thing. I went ahead and multiplied my exponent. So this becomes x to the 8th, y to the 12th, x to the negative 8, and y to the negative 16. And then I realized I was multiplying stuff with the same base. So I combined my x's and I combined my y's. And at this point, hopefully you remember that now I can, for my x's, my base of x, I can add my exponents together. 8 and a negative 8 gives me 0. And I can add the y exponents together. So y to the 12th, y to the negative 16, 12 and a negative 16 is a negative 4. And then I just cleaned up a little bit. So x to the 0 power, well, that's 1. Anything to the 0 power is 1. And I don't like the negative exponent, so I stuck it down in my denominator. I got 1 over y to the 4th power. Well, as always, guys, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, let me know. And I'll see you guys soon. Bye.